Today's notes are on solving radical equations. I'm going to briefly read through the directions for solving radical equations. You guys can take a moment to write them down, but I will also repeat the steps as I go through each example. Step 1 says to isolate the radical. So when you're doing this, you need to follow the order of operations and remember that a radical can be written in exponential form. So sometimes it's helpful if you convert between radical and exponential form. You'll see when I do that on some of the below examples. Step 2 is to square or cube root each side to eliminate the radical. If this is written in exponential form, raise each side to the reciprocal power. Step 3 is to solve, and when I say solve, it's solve for the variable. And step 4 is to check for extraneous solutions. This would be solutions that do not work. So pause your video and take a moment to write these steps down. I'm going to begin to go through the first example. I'll list out each step as I go through it. For number 1, we have 3 plus the square root of 2x minus 3 equals 8. Step 1 in the above steps tells us to isolate the radical. So I'm going to move 3 to the opposite side. This gives me 2x minus 3 is equal to 8. All right, step 2 is to square each side. When you square a square root, you're essentially creating two of the same thing. And when you simplify it, whatever is inside simplifies. This becomes 2x minus 3 is equal to 8 squared, which, back up, sorry, I wrote 8, but 8 minus 3 is 5. Okay, so 2x minus 3 is equal to 25. Sorry about that typo. This would be the second step, and the second step was to square each side. Now that we squared each side, we need to solve for x. Solving for x would mean we need to add 3 to both sides. This gives us 2x is equal to 28. Divide both sides by 2, and x is equal to 14. So this is our solution. Before we can officially say this is our solution, we do need to check for extraneous solutions. And checking for extraneous solutions means we substitute our answer back into the original equation, and we solve to make sure it comes out to be true. If it comes out to be false, we label it as an extraneous solution. Our solution here is going to be 3 plus the square root of 2 times x, or 2 times 14, minus 3, and this is equal to 8. When we simplify this, we have 3 plus the square root of 28 minus 3 equals 8. 28 minus 3 is 25. 3 plus the square root of 25 equals 8. 3 plus 5 equals 8, or 8 equals 8. So this is correct. Therefore, we know that x equals 14 is our solution. It's our only solution. Again, you do have to check for extraneous solutions. You will end up with them sometimes. And extraneous solutions just mean solutions that do not work. For number 2, we have the square root of x plus 7 minus 5 equals x. I'm going to start by isolating the variable, so I add 5 to both sides. This gives me the square root of x plus 7 is equal to x plus 5. After you isolate the radical, step 2 is to square both sides. On the left side, if you square a square root, you're left with x plus 7. On the right side, x plus 5 squared is the same as x plus 5 times x plus 5. When you are multiplying two terms together, you do have to distribute, so multiply all terms. X plus 7 equals x squared plus 5x plus 5x plus 25. X plus 7 is equal to x squared. 5x plus 5x is 10x plus 25. Okay, anytime you end up with an x squared term, you're most likely going to have to either factor or use the quadratic formula. So if you are doing either one of those, you need to make sure your equation is set equal to 0. In order to set this equation equal to 0, subtract 7 from both sides and subtract x from both sides. This will create a 0 on the left. This is equal to x squared plus 9x plus 18. And at this point, you can factor. Or use the quadratic formula, either way, because this is equal to 0. So I'll write a little note off to the side. If you have a squared term, or have a variable squared, set the equation equal to 0. And solve for x. Solving for x means you will need to factor. All right, so looking at this expression, x squared plus 9x plus 18. What two factors multiply to 18 and the same two factors that add to 9? So that would be 6 times 3. I'm going to rewrite this expression as x squared plus 6x plus 3x plus 18. Factor out an x plus 6. Factor out a 3, x plus 6. We have 0 equals x plus 3 times x plus 6. And at this point, you set each factor equal to 0, giving you a solution of x equals negative 3, and also a solution of x equals negative 6. Before we can officially say those are our solutions, we need to test our answers in the original expression. So we're going to take this expression from above, bring it down, test our values. So we have to test when x equals negative 3, and we also have to test when x equals negative 6. Testing when x equals negative 3, this gives us the square root of negative 3 plus 7, and this is minus 5 outside of the radical, and that's equal to negative 3. So the radical expression will be the square root of 4 minus 5 equals negative 3. Add 5 to both sides. The square root of 4 is equal to 2. And that is true because the square root of 4 is 2. So we know that x equals negative 3 is a solution. Next, we're testing x equals negative 6. This gives us the solution of -6 plus 7 minus 5 is equal to -6. -6 plus 7 is the square root of 1 minus 5 is equal to -6. Add 5 to both sides. The square root of 1 is equal to -6 plus 5, which is -1. The square root of 1 is 1, not -1. So this right here is not true. That means this value or the solution of -6 is an extraneous solution. And our only solution is x equals -3. So number 3, I'm gonna get started on number 3 for you. I'm gonna talk about how to solve this, and then I'm gonna solve number 3 and 4 without speaking through them. You can just follow along with my work. So to start off with, for number 3, you need to recognize that it's not a square root, it's an exponent of 1/2. So you can either leave this as an exponent or you can convert it to a square root, because remember that an exponent of 1/2 is a square root. So that's what I'll do here. I'll rewrite 4x plus 1 as the square root of 4x plus 1, and this is equal to 10. Then I'm going to divide both sides by 2 to isolate the radical, leaving me with the square root of 4x plus 1 is equal to 5. And just follow along as I complete the rest of this one and number 4. Okay, so we just went over square root examples, and to do that, we we squared both sides and solved for the variable. Next, we're going to go over cube root equations, and in this case, we cube both sides and we solve for the variable. So for number one, just to point out, you can see this is a cube root, so make sure you always notice the difference. But the solving process is the same. So I'm going to subtract 1 from both sides. This gives me the cube root of 3x plus 2, and this is equal to -1. At this point, I'm going to cube both sides, and again, I cube it because it's a cube root. On the left, I have 3x plus 2, and on the right, I have -1 times -1 times -1, which is -1. Subtract 2 from both sides, 3x equals -3, divide both sides by 3, x equals -1. And just like with square roots, you do have to check for extraneous solutions. So when we check for this, we substitute -1 into the original equation, giving us 1 plus the cube root of 3 times -1 plus 2, and this is equal to 0. 1 plus the cube root of -3 plus 2 equals 0. 1 plus the cube root of -1 equals 0. 1 plus -1 equals 0. That is correct. So this is your answer. And just to go back to that, the cube root of -1 is -1. Cube roots can have negative answers. And for number two is in the form of an exponent. I'm going to change this to a cube root. So 2 times the cube root of 6x minus 3 minus 4 equals 0. We have to follow order of operations, so I need to add 4 to both sides. 2 times the cube root of 6x minus 3 is equal to 4. Divide both sides by 2. The cube root of 6x minus 3 equals 2. At this point, I can cube both sides, and it would be 6x minus 3 is equal to 8, of which we add 3 to both sides. 6x equals 11. Divide both sides by 6. X equals 11 over 6. So you do have to check this answer, even though it is a fraction. You should still check it. So to check this, we end up with 2 multiplied by 6 times 11 over 6 minus 3 raised to the power of 1/3 minus 4 equals 0. Now, if we look at this fraction, 6 and 6 are going to cancel. Technically, that's 6 over 1 times 11 over 6. You can cancel the numerator to the denominator, and that leaves you with just 11. So 2 times 11 minus 3 raised to the power of 1/3 minus 4 equals 0. 2 to the power of 8 raised to the power of 1/3 minus 4 equals 0. 8 to the power of 1/3 is the same thing as the cube root of 8, and the cube root of 8 is 2. 2 times 2 minus 4 equals 0. 4 minus 4 equals 0. That is correct. So this is your answer.